we're going to switch over to one of our actual live ELSI discussions. So the idea here, folks, is that we're going to have up here a couple in this first case of our ELSI advisors and one of our researchers here at CASE, and they're going to have a conversation and they're going to talk to one another, and then you all can raise your hands and ask questions of them as well. So we're going to show you live what an ELSI conversation looks like. So hopefully that will demonstrate it. And as a perfect lead-in, this one does involve AI. So please come on up, our speakers here. So what I'd like first is very briefly, if you could each introduce yourselves.
Hi, good morning. Erman Ede. I'm a faculty member at CASE in the computer science department. Just a disclaimer, I'm not an ELSI expert. I work with ELSI experts, so I'm here to maybe just describe my point of view in terms of ELSI and learn from others. So nice to see you all.
Hey, I'm Dr. Puchpakuchi, and I work for the Institute for Defense Analyses out of Washington, D.C. And we are, I kind of like to say, we are the private little think tank for the Office of the Secretary of Defense. And so for the last 6 or 7 years, I've been working pretty closely with DARPA, with a great team at IDA, talking about the ELSI impacts of their technology development. And if you don't know DARPA, it's the Defense Advanced Research Projects Agency. They are the guys that are supposedly doing the cutting edge. What are the next technologies that might be affecting our military?
And I'm Mitt Regan. I'm a professor at Georgetown Law School. I teach a course on AI and national security. I've been an ELSI advisor with IDA, the organization that Pooch just described, on projects involving DARPA. I also do work on ethical issues relating to AI with NATO and with Norway, and also have a background in international law, international humanitarian law, and human rights law.
And with that, you have some slides, correct?
I just wanted to, facilitate the discussion a little bit, just to, give you a couple of examples about the things that we have been working in XLab and in my lab. And by the way, my background is completely about data privacy and cybersecurity. Data privacy part is more close to ELSI probably. Like I said, I'm not an ELSI expert, but I work with a lot of ELSI experts over the past. So Lynette is one of them. She's in the room. I work with people from our medical school, from our law school. And this is mainly because of the nature of the data that I've been probably working on. I was working on healthcare and specifically genomic data privacy over the last 10-15 months, and we have developed several solutions by showing the risk and mitigating the risk. But today I'm just going to show you a couple of real-life examples without going into too much technical details, and then maybe we can then discuss over those types of things. What I'm really curious is, what type of things we have been missing in terms of ELSI components, and what type of things maybe we are maybe even exaggerating. And I actually have a message as well in terms of the technical requirements to meet ELSI at the end, so I'll mention it at the end of the talk. So and I'm sorry about the typo for the last item, I just realized it. So I put the asterisks because these are basically the requirements for trustworthy AI and ELSI related requirements from my point of view. Obviously, this may not be a complete list. Obviously, there are some terms that we are not even allowed to use these days, unfortunately, but these are mostly the technical parts. Right? And these are all the things that we have been working in my lab, in XLab, over the last few years, 5-10 years. One thing that I want to highlight is, these are technical requirements. We have been developing technical solutions in order to meet these technical requirements in the AI landscape, in data analysis landscape. And not just us, obviously. I mean, thousands of different researchers are doing the same thing. Most of these requirements, they look trivial to meet. But when the challenge is this: you want to actually meet all these requirements at the same time for a given system or for a given algorithm. And most of these things are in conflict with each other. You try to meet privacy. If you want to do privacy, you need to, the reproducibility becomes a big issue. If you try to, provide reproducibility by sharing your data sets with each other, then you kind of lose privacy. So meeting these requirements together actually is the big issue. So this is what we have been working on, to make sure that we actually meet these requirements all together by default for a given system, so that when we provide the system to the end user, they can actually make sure that all these requirements are met in the system. So just Let me start with one example. Again, you can just check the figure, but I'm not going to talk too much about the technical details, and I want to really do this presentation very short. So this is one of the architectures actually we have been proposing. And the motivation of this is, I mean, in today's landscape, there are these big data lakes, right? There are these big service providers who want your data so that they can get your data, they can build their AI models, and once they build their AI models, they can actually provide you some personalized services. The problem is these service providers, they work like data lakes. They get your data, obviously they get your data with your consent, but then they share your data with others. You know, they do all sorts of analysis with your data, the models that they generate. You don't know how reliable or how fair they are. So what we came up with, this very simple idea. So what if we don't actually share our data in these data lakes? What if we actually can keep our data on ourselves? In other words, user actually has the full control over their data, which is complete distribution, right? So the complete distribution is obviously a no-brainer. So you can always propose that. So you can say that, you know, whatever I generate, for example, using my cell phone, I'm not going to send this to the service provider. I'm going to keep it on my end. But the challenge is this: you want this complete distribution or decentralization, but at the same time, you still want to benefit from all these services, right? You still want to generate these big AI models that are going to be useful for you. You still want to get the benefit from these personalized services. So as a result, complete decentralization without the corresponding algorithms is obviously useless. So what we have developed is actually a novel architecture with the corresponding algorithms that actually can create today's landscape, today's ecosystem, in which we can still build these AI models, we can still get benefit from all these personalized services, but we don't really need to compromise our data to these data lakes. We can actually keep full control over our data. It doesn't mean that we are never going to share our data with these service providers, but we can have full control, meaning that we can actually control who sees our data, how much of our data they can see. If I want to revoke my data, we can actually revoke our data, access to our data immediately. So this architecture actually provides that type of a system. So this is a very abstract architecture. You may be wondering, so what is it used for? So I'm going to give you a couple of examples how we actually utilize this architecture to solve some real-life problems. So the first one is actually collaborative research, and this is an existing ongoing NIH project in which we wanted to actually see if we can make collaboration easier across medical researchers, especially when they want to build AI models, when they want to do collaborative research. So what's the issue? The issue is, I mean, everybody likes to collaborate, especially medical researchers, but the first rule of collaboration is if you want to collaborate, you end up exchanging some data sets, right? I have a data set, you have a data set. We need to somehow merge our data sets or exchange our data sets so that we can do collaborative analysis, we can build collaborative machine learning or AI models over our data sets. So exchanging these data sets is tough. The reason is sometimes it's not allowed by policy, right? Sometimes it needs to go through IRB approval. That IRB approval sometimes may take months, which is a huge limitation for research. And at the end of the day, you know, even if you get the IRB approval after a couple of months, exchange the data sets, maybe the end of the research is going to show you that it wasn't really a good idea, right? And then you will need to find a new collaborator. So we started this idea as a very roughly, and I know it's a very, the informal term, but it was meant to be a Tinder for researchers, where actually they can meet, they can identify each other without exchanging data. It's a sandbox environment where actually the researchers are meant to meet and figure out who should collaborate with whom. So they can actually see the preview of their research without exchanging data. So that was the initial idea, and then it kind of escalated. We could actually provide all these services in this sandbox by using the architecture that I showed you in the previous slide. So they can actually explore each other's data set, they can identify high-value collaborators, they can conduct collaborative research and learning, they can do collaborative pre-processing. This is very important. They can actually pre-process their data without even exchanging data with each other, which is crucial because without the pre-processing, the resulting AI models tend to be unfair and sometimes biased. So they can actually remove all the data records that are going to create bias even before they start their collaboration. Then they can build the AI models. We can actually provide privacy-preserving reproducibility of the models, because when you create an AI model, one of the things is if you are providing that AI model as a service to the end user, what happens is the end user sends you a sample, you classify that sample using your AI model, you provide the classification, right? But the user has no idea, I mean, if it's an accurate classification, why did the model decide it in that way because of that classification? So there are a lot of question marks, especially in medical domain, especially if that classification is going to be used for healthcare, right? So as a result, we also provided this reproducibility feature, which actually allows users to make sure that the model is constructed correctly. The classifications that the model provides actually make sense in terms of whoever is going to use that classification. And more importantly, we provided something called transparency. So the users that use this sandbox actually are very much aware of their potential privacy risks. So what if they make their model publicly available? What if other people use the model? What are the potential privacy risks from the end user's point of view? If they share their data with the model developers, what's the potential privacy risk of sharing that data? So all these things are also included in this model. And because of this interdisciplinary nature of privacy, or the ELSI, so we have started this in terms of medical research. 1 year ago, or a couple of 2 years ago, actually we realized that very similar platform is actually very much required by farmers as well. Completely different application, especially when they use digital agriculture. So digital agriculture is when they actually collect data from their farms and they want to learn more about their farms by collaborating with each other. So we actually started building a similar architecture for digital agriculture so that the farmers can actually benefit from the similar structure as well. Another interesting use case of the application, and this is the last slide, that we have been doing for the last 2 years with collaboration with Walmart Foundation is learning employee records. So the learning employee records, I'm going to keep it oversimplified. It's basically the interaction between students or the job candidates and the employers, right? So just try to remember the ecosystem. So the students or the job candidates, they have their lifetime learning portfolio, which may include their transcript, their certificates, everything that they have during their lifetime learning, right? And the employers, they have some job postings and they want to find the best candidate. So we actually use the same architecture in order to solve this system in a privacy preserving, verifiable and fair way. How we achieve this is we make sure that the students or the candidates actually keep their credentials, their transcripts, their certificates, whatever they obtain throughout their lifetime learning themselves on their side. We built AI models. We used AI models in order to generate derivative micro-credentials out of these documents. Because, you know, when you give a transcript to an employer, the transcript is, I mean, it has a lot of pages and it's very hard to process it, so you need to make it more understandable. So by using the AI models, we actually transformed the transcript into a more understandable form. So for example, if there are any CS students among us, so by processing your transcript by using AI models, we can actually say that whether or not you are an expert in Java or in operating systems or in programming languages, and that's what employers actually wants to see at the end of the day. We can do the same thing for the certificates, we can do the same thing for recommendation letters. We do this in a completely decentralized way, but the thing is, when you decentralize things, you also need to have the verifiability aspect. So when I generate these micro-credentials or derivative credentials on my end, you need to make sure that I generated them in a correct way, in a verifiable way. We also included that verifiability aspect here so that we can actually generate all these things. And then we do the similar thing on the employer side, because the employers, they have their job postings, right? A couple of paragraphs of job postings. By using AI models, we also transform these job postings into these micro-credentials as well. And when you do so, then it becomes like a matching issue, right? Between the job posting and between the credentials of the student. We do this matching in a privacy-preserving way, and at the end of the day, the student doesn't need to send any personal information to the employer in order to do this job search. And the employer only sees the result of the matching without even needing to see any demographics about the potential candidate, which actually also provide fairness, right? All the employer only sees that, you know, these candidates are a good match about what I'm looking for, and it would be a good idea if I go and do an interview with those candidates just based on their skills, just based on their credentials. So yeah, just wanted to, you know, mention this. And maybe just one last thing. So over the last maybe 5-6 years, we have raised more than $7 million in these types of research. So I just want to tell you that there's a huge interest on this front. If you are willing to continue your career on this front, there is still a huge possibility. We have developed these sandbox architectures. We are still doing it. One interesting thing is we are actually working with IRB departments of different schools, including Case, Rutgers, UT, University of Texas, in order to build these things. So they are also involved, and they also believe that there is a good potential investing in these sandbox environments in order to make the IRB process more faster and more efficient. And I guess that's all from my side, so I'll just leave it to you to learn more. Thank you.
What sort of access to what kind of resources do users? Oh, I'm sorry. Yeah. What kind of access to what kind of resources do users need in order to be able to participate in a system in which there is this sort of control over most personal identifying information, and only a subset of that is transmitted to the service provider?
Yeah, that's a great question. The user, you mean, I guess, the end users, right?
Yes. Right.
So you don't really want to change how the system flows from the end user's point of view, because it would be too much to expect from the end user to understand the technical background and to control all those settings. Right. So what we have been trying to do is we try to do all these things by default. And then if the end user really wants to, play with the controllers, play with the settings, then, they can make their privacy settings more customized. But by default, actually, we provide all these strict privacy and, other ELSI-related attributes to the user.
Okay. And I'm also just thinking, are there any sort of what's called digital divide issues here? That is, are there certain segments of the population for whom this will be more difficult? An option as opposed to others?
Depends on the application.
Yeah.
I mean, if the application that you are trying to deploy really requires smartwatches or smartphones that you need to use to collect data, yes. But typically these types of things are actually, at least that's what our expectation or at least experience is, they are outsourced by the companies who actually want to use these types of services on some users. So we have worked with some companies before that they were willing to actually provide these types of wearables to their, for example, employees in order to use these types of services in their work environment. So as a result, I mean, yes, it may be an issue if you have a really large-scale deployment, but depends on the application.
Okay, yeah, and just one final question. I'll let Pooch jump in. Of course, related to that is, so the information that is transmitted to the service provider, that becomes part of the training data for those models there. Mm-hmm. And that sort of relates back to the question of fairness or equity. To the extent you don't have a representative user population, you're going to get models that are skewed in a certain direction, right?
Exactly, that's a big thing. So first of all, most of the solutions that we have been proposing, they don't require the data to be transmitted to the service provider. They mainly rely on federated learning idea, so that we don't really need to transfer any data, regardless how many people use the model. And the second thing about the fairness is, we have been actually doing some research on personalized federated learning, which actually makes sure that if I'm building a model or if I'm contributing building a model, actually I know that at the end of the day, that model is going to be useful for me. Or I can actually identify whether a model is going to be useful for me or not, depending on the distribution of their training data set. So, and I completely agree, it's not like one size fits them all. You can build different machine learning models, and those models may work differently in different populations. So we try to also mitigate that from the beginning and inform people that, this model is going to be the most useful model for you, depending on considering your data and the distribution of that, distribution of the training data set that is used to train that data. But yeah, it's a big problem.
So let me just say that from a starting point, if you are developing a technology and your starting point is, hey, there's this ELSI problem that I would like to ameliorate, you're always standing on better ground than if you're like, hey, I wonder if I can design this. It's always a good starting point. It's like, here's an ELSI problem. Okay, what can I do to help solve that? So, kudos.
That's in academia, it's easy. the problem is you cannot do it in industry because there, like Sharon also mentioned, I mean, there is a big race, there is a big competition, especially in AI domain. It's very similar to how it was 30 years ago at the beginning of the internet.
Right.
Nobody cared about security or
like,
privacy, and then after all these data leaks, data breaches, now people trying to fix it, but by using some batches, not by default.
It's also still very, very true that most of these data collectors, especially at the large end, that data is fundamental to their business model, and understanding what they can do with it, and sadly, the selling of that data is what keeps them soluble. And so, ELSI is very much about what are second and third order effects here, and thinking if they don't have access to this data, or that data is in some format which makes it harder for them to monetize, then what happens to these firms that are currently pushing the technology? And that's a balancing act, right, between privacy and allowing these firms to continue to push that technology, and just figuring out where that balancing act is.
Maybe just very quick thing. You are completely right, and nobody is going to adapt these types of solutions in terms of big tech providers if they have no benefit. And currently, I haven't maybe discussed about that benefit because they are losing a lot, right? Right now they actually have the data. They can do whatever they want with the data. With these solutions, we are kind of preventing them to get the data. We are still allowing them to provide their services, create their AI models, but they don't see the data. So but at the same time, they need to have a benefit. Otherwise, I don't think they will ever adapt. So the benefit is this: when you distribute this, right? So I'll just give maybe a quick real life example, right? I mean, most of you probably use Spotify, so the type of data that you generate in Spotify is the songs that you listen to, how long you listen to those songs, the artists that you like. But the Spotify doesn't collect your healthcare data probably, right? So what's your heart rate when you are listening to a particular song? Maybe it changes, right? Maybe it gives some information about your taste. But Apple does. It does? Does it collect? Okay, that's a bad example. Not yet, okay. But Apple collects it in terms of Apple Health. So when you distribute things, you keep all this data on your end. Your Spotify data stays with you. Your Apple Health data also stays with you. Now, tomorrow, if Spotify actually wants to create a model, AI model, by also using these health data, with this solution that we are proposing, it can do it because it actually has access to that data as well. It doesn't need to see that data, but it can use the data to create AI models. So that's the benefit to the high-tech providers, so that they can actually use a much more wider variety of data when they build these AI models in an ethical way.
I know there's some concern with federated learning about the environmental impact because of the compute requirements. I take it, though, that is mainly if you have users who are actually running localized models on their data. But it sounds like that is not occurring here. Is that right? Or tell me how exactly
It is more expensive than doing centralized training.
Uh-huh.
I mean, if you just collect all the data in a data lake and then do the training, it's less expensive than federated learning. Federated learning has these bandwidth issues, and it adds up some computational complexity to the edge devices.
Right.
That's right. There's not a significant difference.
Okay.
But my defense on that front is, at the end of the day, at the end of federated learning, at least you kind of shoot two birds with one stone, which you create the model, and you create the model in an ethical way without actually collecting the data.
Right.
So if you want to compare it with, for example, blockchain, so it's just a waste of energy to prove something that's not going to be useful at all after that 10 minutes.
Right. And it also suggests, there may be trade-offs at certain points, right? Privacy and environmental impacts, depending on, right? And how do you approach those? I mean, there's no sort of algorithm for determining what are the weights of the various values that may be, as you say, in tension sometimes. I'm just curious how the folks in your field
environment impacts, or
more generally, there are a set of values that you indicated at the beginning that are in some tension to some degree, and you are attempting to harmonize those, achieve those as much as possible. But there may be some trade-offs. You maybe get less of this or more of that. How do folks in your field think about how to assess those trade-offs?
Well, it's a great point. So it's very much application dependent. I have been working with healthcare professionals for a while. So when and there's always a trade-off, like you said, right? I mean, first of all, I'm a privacy expert. There is no such a thing called 100% privacy. So you need to always quantify the privacy. You need to decide how much is enough. That how much is enough is still an open research question. Nobody knows. There are lots of different metrics that you can use to quantify privacy. Depends on the application. For example, you work with healthcare professionals. One thing to provide privacy is obfuscating the data. You can actually you can add a slight noise to the data. That may actually help a lot in terms of privacy. When you talk to a medical professional, that type of obfuscation is out of the table. They never accept such a thing, so you need to find different solutions in order to do that. Because I mean, the data is at the end of the day is used for healthcare, and those small obfuscation may lead to some potential errors. They never accept that. But when you talk to farmers, it's okay for the farmers because I mean, plus minus something in the computation result is not really a big deal for the farmers. So that's why it's very much application dependent. Whatever they want in their application, do they want reproducibility and privacy together, or do they want, for example, verifiability and privacy? That's why we try to, balance them, and it's always an optimization problem.
Well, and that raises the question as well, how much is there sort of stakeholder consultation?
It has to be a lot. So
I was going to say
you cannot just sit and. Yeah.
I know in the work I've done with a while back is that's often the weak link in a lot of these. There isn't really, or they think of stakeholders in a very limited sort of way, and so there is that sort of engagement.
Yeah, that's why I mean I've been personally collaborating with a lot of people from different application domains, because otherwise, and maybe at the very beginning of my career I did otherwise, just sitting and speculating on behalf of these people, but it never works because you generate a solution that you think it's important, you present it in front of that audience, and they say that, this is nothing. So as a result, I mean, you need to have that stakeholder engagement, maybe not overdo it, but you need to have it periodically so that you make sure that you are on the right direction.
Early in the process.
Especially in the problem definition, because typically, especially if the problem comes from them, then it's easier for you to solve it rather than you try to come up with artificial problems.
I'm not stopping you, but I wanted to point out that those in the audience, this would be a good time if any of you have questions for our folks up here. If you'd like to just raise your hand and engage with the conversation, just go right ahead and just speak up a little bit so we can hear you up here. Yeah, go right ahead, Nick.
I stand up because I moved up because the back of the room can't hear the question.
Oh, okay. Oh, we have a microphone for you. Oh,
Right, Nick, here we go.
Brilliant. Thank you. Yeah.
good, thank you.
There's some over here too. We forgot about that. My bad.
So this is a simple question, I think. I mean, it's a short question. How do we go about determining the defaults in the sandbox?
How do we go?
Yeah, how do we determine what the defaults ought to be in the sandbox?
For those who aren't as technically advanced to do it.
What we envision this as an open source platform. So we are not really claiming to provide any defaults for anyone. So this is just an open source platform. The only reason that we have been developing these algorithms is to show people that what types of things can be done by using this type of an architecture. But then what we envision is people are going to adopt this, they are going to build their own algorithms, they are going to decide their own defaults. If they need help, obviously we are more than happy to help in terms of what the privacy defaults should be or what type of metrics exist out there in order to decide on those defaults. But we cannot really, realistically, we cannot decide on those defaults for every different application because different applications, they have their own defaults. When it comes to privacy, reproducibility, verifiability, sometimes they need it, sometimes they don't need it. And the privacy is always different in different applications. Sometimes it's unacceptable to have any, for example, de-anonymization risk. And sometimes, for example, in today's large language models, right? So the de-anonymization is not the worst nightmare for LLMs, but attribute inference, apparently, right? If somebody is actually used in the training process of a large language model, and if you can actually somehow get that data by just sending some particular prompts to the model, then it's a big nightmare. It means that the model is actually leaking information that it used during training. So that's why I say it's a very application-dependent question.
Can I jump in real quick?
Yeah, and I think Nick had a follow-up.
So I think that, to me, I think this is precisely the challenge, right? This is the market economy theory, right? That the user themselves has enough knowledge to know what their defaults ought to be. and they understand and they can see the edges of the system to be able to make those kind of intelligent, decisions. I've got 2 daughters, and I'm talking to them all the time about their privacy, and their response typically is, "I'm not a criminal. I really don't care." And it actually helps me to get the information that I need. Amazon tracking me and my purchases allows me to know what I need without giving me supposed garbage in another way. They're not understanding the edges of the system, right? And so it seems to me it's problematic to think that a user can define their own defaults with full
I misunderstood your
intelligence.
question. Then I thought you are asking the defaults from the service provider point of view. For the user,
Well, I initially thought you were talking about
no,
defaults
the user,
that were
user is
pre-established.
easier. For the user, I mean, by default, generate your data, don't share your data with anyone unless you provide your consent. So in other words, privacy by design or privacy by default. And then unless the user decides not to do. So just maybe remember the privacy settings of Facebook 10 years ago. By default, it was open to everyone. Everybody's profile was open to everyone. I guess now they changed it. I'm not using Facebook anymore, but I guess now it's better. But if we are talking about those types of defaults, I guess the user defaults are going to be just generate your data, keep it in your compartment or in your local database. Don't share it with anyone. But then if there is a request to use your data, then you can just decide on the request by just click of a button. You don't also expect the user to know too much about the technical details about those things, right? But if you are curious about the consequences of clicking accept, then we provide that transparency as well. We provide the consequences, potential privacy consequences or potential ELSI related consequences of accepting to be a part of any study.
Just quickly, I know we have you standing by. Rich, if you could help me out, I'm going to borrow that mic from you for one moment. And I'm going to torture the students at the front. So they're talking about your generation. If you could just walk over there for a second, Rich. Do any of you want to comment on, do you fall where Nick was saying his daughters do, that you don't care about privacy that much? Is that unfair as a sweeping statement? Anyone willing to speak? Come on, don't be shy. Oh, there, we got one. We got to take her. In the front row here. Yeah.
I feel like within on TikTok, there's been a lot of discourse with them banning it and everything. And there's been a lot of talking about, they're taking your data. And then there's people saying I don't care. What are they going to do with it? So I definitely do feel like there is kind of a lot of thoughts within this.
Yeah, they're just apathetic about it.
It doesn't matter. What are they going to do with the fact that I liked a video about mascara or something, So I definitely feel like it's probably important to educate on that because I myself don't know if it's okay for them to have my data. You know what I mean? Yeah.
And of course, the answer is always a wonderful answer, and it's going to come back very complicated because you're quite right that maybe it doesn't matter, if they know that you liked a particular video, but down the line, maybe something that you were briefly excited about is something you don't want to be associated with, and then forever it's permanently connected to your name. And I think that's what we worry about a lot is that you go through different phases in your life. You may be interested in something, and someday, this is a bit of a silly example, but someday you're running for office and people are like, but you liked this video in back in 2025 about this or that, and you have to explain that. However, it may be the case that because of these changes, maybe that won't happen as much in those future political environments because everyone will be in the same boat. That's another possibility. Everyone will be like, well, we can't reach that far back because we'd all have something that we wish we hadn't clicked on. Yeah, go ahead.
Hello. I will say that our generation has become almost fully reliant on the data being collected. I know someone who has a fridge that will schedule to order them milk when they run out because it just can tell. And I think that's terrifying, but also it's just what we're used to by now, and I don't really know that if we understand how our data is actually being used.
Mm-hmm. That your classmate wants to. Yeah, I mean, I'm a little terrified by that too, and that is that unskilling that I was talking about. And of course, we worry about what if it all stops working and nobody knows how to do anything. Go ahead.
Yeah, I mean, I feel like it's so normalized in our generation and future generations as well. your guys' generation, like you grew up with technology being introduced, like you've seen the early stages, like the earlier computers, and like we kind of grew up with like, I wouldn't say that our generation like grew up on technology, like we have had it since a very early age, but like the generation after us, I mean, there are children like on iPads, like revealing stuff. Like there's been stories of like kids buying like stuff on games with like their parents, like credit cards and stuff, like giving out like their parents' information and stuff. And I feel like our generation is like, we know a lot about technology, or at least we think we do, but we do kind of do stupid things because we've just had that since an early age to be able to like go on social media and post ourselves like out with our friends and like everything like that. I feel like we kind of don't know like the possibilities or like the full like variety of what we fully share online and like the full consequences. Like, and especially I feel like it's just going to keep getting worse with like future generations because there's no like courses or anything that like teaches us what not to do, or like, oh, like there's so many websites now that like can take your information and people just like accept all cookies, like just share all of what I do. And like, especially where there's all that stuff where like Facebook listens, I mean, where you like, I've talked about things like with my family and then all of a sudden I'm getting ads with it. Like there's no like full knowledge of like how far they truly goes.
It does really listen, by the way, because it has all these sub companies connected to Facebook. I mean, Facebook maybe, or Meta, right? It doesn't have access to your micro.
Yeah, TikTok.
No, she said Facebook. I don't know TikTok. I don't know. I don't have the same example over TikTok, but you know, Facebook, WhatsApp, same company, right? It's just a Meta. WhatsApp has to access your microphone, otherwise it's useless. It's a communication tool. Facebook, maybe you deny accessing to your microphone, but if one accesses to your microphone, they keep listening. They will get that information. They share that information within the company, and this is not really speculation. They really do that, and then they kind of merge that information to your profiles across different platforms to get to know more about you. And I'm not blaming you, and you will keep using these services. And it's not a bad thing to use these services. That fridge is good, actually. It's cool fridge, right? I mean, nobody is going to blame anyone to use that fridge. The thing is, how they collect the data is the important part. Like Shannon said, I mean, maybe 5 years, 10 years from now, they may try to use that information against you, which I find it unlikely a little bit. But what's worse is, you know, they keep collecting this information. They create a profile of you. Maybe they know you even better than you. And then they start sending you messages to manipulate you, right? I mean, that's I guess the main threat. They know you better than you. They know your potential actions. They know how you are going to act as a result of some potential action, and they will start using these things against you when you are voting, when you are doing some certain actions. So I guess we need privacy, we need data management, data control in order to prevent all these types of things, not to, you know, avoid you from using those services.
I want to let Pooch jump in here, but I just wanted to admit that as a humorous bit of rebellion, one of the things I do is I try to mess with algorithms. So like when I see them trying to get to know me too well, I try to do something out of character so that they will, like, yeah, you think I'm an ethics professor? Well, I've seen all Sharknado movies. So, you know, anyway, but you want to mess with them a little bit so they can't predict you. Go ahead.
Just to start with, don't think that the youth have any monopoly on doing stupid things. We do it all the time. But a point that I wanted to bring up that I don't think has become, that we had really touched on yet.
Yeah.
Is, you know, in designing these kinds of capabilities, especially if they're going to be open source or they're sort of a generic architecture which shows you how you can do this protection of data and still conduct transactions, there's a whole bunch of malicious actors out there that would be looking at that and trying to figure out different ways to do that. Now, in DoD, we have this thing called red teaming that business has taken on. But we like to put people in a room, give them a technology and go abuse the heck out of this technology so we can figure out what the guidelines need to be on it. And you know, that's just something to be very, very careful of, is like, we get stuck in this, I can see all of the positive benefits of this particular technology, but it only takes one really bad apple to go, oh, but look what I can do with this. And so being very, very careful with that and trying to put incentives in so that the corporations have some incentive to think about this ahead of time, as opposed to just releasing large language models and saying, go do something with these, and having it show up with citations in lawyers' briefs and things like that of cases that don't exist. It's like stupid stuff, right? But that's the point, I think, is be careful of the malicious actors. And it really, it's also kind of fun to sit there and think, hey, what could I do with this technology if I was a little evil, right? But doing that goes a long ways toward understanding what kind of guidelines you might want to put on this and how to protect it.
And Pooch, a real world example of that would have been the coach that just got arrested for working his way into social media of over 1,000 co-eds at a dozen different colleges and getting into their social media and their boyfriend and girlfriend sexual pictures and then blackmailing them or selling them online to porn sites he did it for 12 years at like 25 different colleges and athletes that were coming to his facility to play their teams and stuff. He had thousands and thousands of social media entrees into their social media posts with their, and intimate social media posts that he then sold online as pornography.
And that's why we need protections, because I would kind of echo something that Pooch was saying. Not only are we all stupid sometimes, but also I want you all to be able to be a little stupid. You're allowed to have some fun, and it shouldn't be so vulnerable when you do that. We're almost out of time for this session. We're running a little bit behind. So we're going to wrap this up here, but then we're going to give a little bit of a break so that people can run to the restroom and, most importantly, go to the exhibit hall next door and see all the cool tech that we've got there. So rather than reconvening at 11, we're going to reconvene at 11:05. It's not that much longer, but we're going to give a little bit of a break since we started late. And so we'll see you all back. And if we could just thank our panelists, please.